Hi there. Tonight, we're going to learn how to find vertical and horizontal asymptotes of rational functions. So, let's evaluate the limit as x approaches infinity of f of x and the limit as x approaches negative infinity of f of x for the following rational function. We're going to use infinity or negative infinity where appropriate, and then we're going to give the horizontal asymptote of f, if any. So, the function in question is f of x equals 16x squared minus 8x plus 9 divided by 4x squared plus 2. So, to evaluate the limit as x approaches infinity, first we have to divide the numerator and the denominator by the largest power of x that appears in the denominator. So in our case, that is x to the power of 2. So we're going to say that the limit as x approaches infinity of f of x equals the limit as x approaches infinity of 16x squared divided by x squared minus 8x divided by x squared plus 9 divided by x squared, all divided by 4x squared divided by x squared plus 2 divided by x squared. Okay, so we can clean this up algebraically quite a bit. And now we can say that this equals the limit as x approaches infinity of 16 minus 8 over x plus 9 over x squared, all divided by 4 plus 2 divided by x squared. Okay, so now we're going to evaluate the limit as x approaches infinity using the limit laws. So we have the limit as x approaches infinity of 16 minus the limit as x approaches infinity of 8 divided by x plus the limit as x approaches infinity of 9 divided by x squared, all divided by the limit as x approaches infinity of 4 plus the limit as x approaches infinity of 2 divided by x squared. Okay, so now we basically, it's not mathematically correct to say this, but we could think of it as plugging infinity in to the denominators of these fractions. And when we do so, this term here all goes to 0. This term here all goes to 0. The same thing in the denominator, as the limit as x approaches infinity of 2 divided by x squared is just simply 0. So we could say this is 16 minus 0 plus 0 divided by 4 plus 0, which is simply 16 divided by 4, or 4. Okay, so the limit as x approaches infinity of f of x equals 4. Now, we're going to evaluate the limit of as x approaches negative infinity of f of x by dividing the numerator and denominator by the largest power of x appearing in the denominator. Then we're just going to use the limit laws and evaluate the limits. So we have the limit as x approaches negative infinity of f of x is equal to the limit as x approaches negative infinity of 16x squared divided by x squared minus 8x divided by x squared plus 9 divided by x squared, all divided by 4x squared divided by x squared plus 2 divided by x squared. This becomes 16 minus 0 plus 0 divided by 4 plus 0. So, for really small negative numbers, the limit as x approaches negative infinity of the function f of x is again equal to 4. So, the horizontal asymptote of f. Since the degree of the numerator is equal to the degree of the denominator, or more properly, the degree of the highest term in the numerator is equal to the degree of the highest term in the denominator, the horizontal asymptote is just simply a over b. So in this case, the horizontal asymptote, which we've shown with both algebra and calculus, is simply y equals 4. Thank you for learning with Achieve Educational Opportunities. Have a great night, and we'll see you in the next video.